Hi everybody, today we're going to talk about tree diagrams and I'm going to focus on probabilities. A tree diagram helps us organize outcomes or probabilities for an experiment that has multiple stages or sequential events. The stages or sequential events are called the branches of the tree diagram, which is where it gets its name. So let's try this example. According to the 2020 demographic profile of the military community from the Department of Defense, 17.2% of active duty members of the military are female. 19.2% of the female active duty members are officers, and 17.2% of male active duty members are officers. Make a tree diagram to find the percent of active duty officers. Before we start, let's talk about the tree diagram to say, because we have different percentages of males and females, and different percentages of the amount of males and females that are officers, we can't just add together the percentages and find the average. We really need to break apart the data and look at the percentages one by one. Let's start with the 17.2% of active duty members that are female. We'll make our first branch, label it female, and put on that that's 17.2%, which I called 0.172. If 0.172% of the active duty members are female, then the rest, which is 1 minus 0.172, are male. That gives us 0.828. Now that we know the percent of males and females, we can go on to the 19.2% of the female active duty members that are officers. I'll make another branch that I'll title officers, and we'll put on the 0.192. The rest of the female active duty members then would be enlisted. So we make another branch titled enlisted. Then to find the percent, we find 1 minus 0.192, which is 0.808. We know that 17.2% of male active duty members are officers. So again, we add a branch, we put on the 0.172%, and then we add another branch to represent the enlisted, which is 1 minus 0.172, or 0.828. Now that we have all the probabilities, we can work on what percent of the active duty members are officers. Let's add a few labels. Remember the 0.172 was the probability of being female. Then the 0.192 is the probability someone's an officer given that they're female. When we talked about conditional probability before, we said if we want to find the probability someone's an officer given they're female, we would find the probability of being an officer and female divided by the probability of being female. We want to isolate the probability of officer and female, so we're going to take this probability of female, multiply it over to the left to get probability of female times probability of officer given female, which will be equal to the probability of officer and female. Then we'll also be able to go through and do the same thing with males. We'll have the probability of male times the probability of officer given male, which will give us the probability of officer and male. So going across our first set of branches, we have 0.172 times 0.192, which is 0.033. We could also find the probability of enlisted in female by multiplying 0.172 by 0.808, which is 0.139. Then the probability of officer and male will be 0.828 times 0.172, which is 0.1424. Then our last set of branches, which would be probability of enlisted in male, is 0.828 times 0.828, which is 0.6856. We are just trying to look at the officers, which means we want the 0.033 and the 0.1424. Adding those together, I'll get that the probability that someone's an officer is 0.033 plus 0.1424, which is 0.1754. We could use the probability that someone's an officer to help us find the probability someone's enlisted. If we do 1 minus 0.1754, we get 0.8246. I hope this shows you how a tree diagram helps us organize probabilities.